Morning, everybody. We are going to look at actually our last lesson of the unit, our last official lesson. It's a combination lesson, and the title of it is actually combination subsets. So the best way to explain combination subsets is to jump into some examples. Okay, let's take a look at example number 1. It says there's a bag with 8 different colored marbles. So the very classic idea of the bag. Now instead of blocks in the bag, we've got eight different colored marbles. How many ways can you choose a group of 8? So again, we learned in our combination lesson that there are certain words that indicate combination. Group, card hand, team, committee, batch. And we also learned that when you're looking at an example like this one with a bag, if your hand isn't delicately going in and selecting one thing at a time, then order is not important. If your hand is going in and you're scooping up 8 marbles in your hand, order is not important. You don't care what marbles you're pulling out. You're not being fussy. You're not being picky. Hand is going in and you're scooping out. So this is very much a classic 8 choose 6 combination. Let's do a recall that it could also be written like this. And let's do a recall of the combination formula being n factorial over n minus r factorial, r factorial. So n being 8, total number of marbles that you have available, 6 being the total number that you're choosing, 8 factorial, 2 factorial, 6 factorial. 8 factorial over 6 factorial is 8 times 7. 2 factorial is 2 times 1. 56 divided by 2, answer of 28. Absolutely nothing new there. Very, very straightforward question. In how many ways can you choose a group of 3 or a group of 4? So a group of 3, hand goes in, you scoop out 3, or a group of 4. 8 choose 3 or 8 choose 4. And again, we can get our calculator out and use our NCR button. 8 choose 3 is 56. 8 choose 4 is 70. Final answer, 126. Again, absolutely nothing new in that example. Nothing new. Okay, let's take a look at C. How many ways can you choose any number of marbles out of the bag? And you and I both know in this particular unit, words have a lot of importance. Little words, and, or, must, at least, together. They all have meaning. Well, we're entering into a new little word to add to our repertoire. How many different ways can you choose any number of marbles? Well, this isn't putting a stipulation on the person choosing the marbles. In the first one, the stipulation was, I want you to put your hand in the bag and pick out 6. Second one stipulation was, I want you to put your hand in and pick out 3 or pick out 4. The third one is very, very open-ended, and it says, hey, just put your hand in the bag and pick out any size. Well, if I was picking out any size, one person could come up and say, I'm only going to pick up one. Or somebody else could come up and say, no, I'm going to put my hand in and I'm going to pick out 2 because I'm not giving detailed instructions. Somebody else might come up and decide, yep, I'm putting my hand in and I'm going to pick out 4. Somebody else might come up and put their hand in and pick out 5. Somebody else might come up and put their hand in and pick out 6. Somebody else might come up and put their hand in and pick up 7. And somebody else might come up and put their hand in and scoop up all the marbles, every single marbles. Okay, so hold on. 8 choose 1 is 8. 8 choose 2 is 28. 8 choose 3 is 56. 8 choose 4 is 70. 8 choose 5 is 56. 8 choose 6 is 28. 8 choose 7 is 8. And 8 choose 8 is 1. So if I add up all of these options, the 8, the 28, the 56, the 70, the 56, the 28, 8, and 1, I get a beautiful answer of 255. Well, what if I said to you, instead of 8 marbles in the bag, that there were 50 marbles in the bag, and I wanted you to choose any number of marbles? It's kind of unrealistic that we would do the question the way we just did. For you to do 50 iterations, 50 choose 1, 50 choose 2, 50 choose 3, all the way to 50 choose 50, and then add them up, I'm hoping that you're feeling like we got to have a better way of doing this. And there is. Let's take a look at a little shortcut. The shortcut goes like this. You've got 8 marbles. There they are. And I know this is weird, but I want you to pretend that you're one of the marbles in the bag, and that you're laying there at the bottom of the bag, and that a hand comes into the bag, and you're seeing the hand come close to you. And if you ask yourself, geez, how many choices do I have right now? You have 2 choices. You could be picked, so the hand could pick you, or not picked. So every marble in that bag has 2 choices. They're either going to get picked when the hand goes into scoop, or they're not going to get picked. So 2 times 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 2, or 2 to the exponent 8 is 256. Uh-oh. Uh-oh. Did I do something wrong? I know the answer, according to the long way, should be 255. But my shortcutty way got me real close, but not exact. Anybody got an idea out there? Anybody got an idea of what you should do? Well, I'm hoping that most of you will say, okay, Miss Martel, just subtract 1. And then you'll get the answer. Now, you might not understand why you're subtracting 1, but subtracting 1 is the right thing to do. Let's talk about why we're subtracting 1. Technically, that subtracting of 1 is known what we call in math as the null set. Okay? It's the set of nothing. I also call it the empty hand set, meaning that the hand goes into the bag and comes out empty. That's not the case in this example. You're not allowed to have your hand come out empty. It very clearly says that you have to pick out any particular number of marbles. So it's not saying that you can pick a certain number of marbles or come out with nothing. So in my answer, the long way, picked out 1, 2, 3, 4, 5, 6, 7, and 8. Within this answer, there's no picking hand going in and not coming out with anything. But guess what? In the short form, the shortcutty answer, this guy has the option of not picked. This guy has the option of not picked, not picked, not picked, not picked, not picked, not picked, not picked. So out of these 256 options, one of those options is the not picked for every single marble. That's why we're removing it. So you cannot have the null set. You cannot choose 0 marbles. You cannot choose the set of nothing. So by removing that 1, what you're saying is, I'm removing the option of the hand going in the bag and coming out completely empty. Okay, one final thing before we look at another example. Can you scoot over to this side of the note, and with a beautiful arrow, can you write this down for me? This is a subset question because you are finding groups of any size. Keyword being the any size. You're not being specifically told group of 3, group of 4, group of 6. Being left airy-fairy, very open-ended. Hey, just get me a group of any size. Just put your hand in and pick out whatever you want. No definitive instruction. When the questions are very, very airy-fairy like that with no definitive instructions, this is the sign of a subset. Okay? Let's kind of ixnay out on that example, and let's get to kind of the more important examples. Okay? Let's flip when you're ready. "18 people show up for the audition for a new hit show So You Think You Can Yodel. The judges can accept as many or as few of the individuals as they wish. How many different combinations of people could they choose to accept into the show?" So this as many as or as few are non-specific instructions. It's like me telling you with the bag, just pick whatever you want. Put your hand in the bag and pick whatever you want. That's very airy-fairy, non-specific directions. Same thing here. You're on the committee to decide who's going to be on the show. And the people in charge of it say, hey, pick as many as you like or as few as you like. So as soon as the instructions are no longer detailed, you have yourself in the situation of a subset. Each person can be chosen for the show or not chosen for the show. So if I'm trying out for this so you think you can yodel, I got two things that could happen to me. I either get chosen or I don't. This is going to occur for 18 people. There's 18 of us trying out for the show. 2 to the exponent 18. But what you always have to remember is that within that 262,144, one of the options, one of them is not picking anybody, and that is not allowed. How do you have a show if you don't even have one person on the show? So picking as many or as few makes the assumption that they've got to pick somebody. So -1 for the null set. Okay, let's keep going. How many different sums of money can you make with a quarter, a penny, and a loonie? So I want you to envision we're going into Tim Hortons and I'm in line in front of you and I order small coffee, a small tea, and the cashier tells me what I owe her and I say, oh, I got some change at the bottom of my purse. Let me just grab it. So I'm standing in front of you and you can see me, my hand is rummaging at the bottom of my purse and I'm saying to you, yeah, I know I've got a quarter down here, I know I've got a penny down here, and I know I've got a loonie. So when your hand is rummaging at the bottom of the purse, again, this is like the marble question. The quarter has two options. It could be picked or not picked. The penny has two options. I could scoop it up or, falls out of my hand back to the bottom of the purse. The loonie also has two options. It could get scooped up into my hand to use or it falls down to the bottom of the purse. So 2 times 2 is 4, times 2 is 8. Now, what we have to be careful of is within these 8 options, one of the options is not picked, not picked, not picked. Now, let's take a moment. Let's take a moment and let's think about the 7 options of the money that could come out, the 7 different sums, okay? Well, my hand could go in and I could just scoop up the quarter. My hand could go in and all I can get a grab of a hold of is the penny. My hand could get in and all I could grab was the loonie. Okay? My hand could go in and I might get a quarter and a penny. I might get a quarter and a loonie. I might get a penny and a loonie. So hand goes in and unfortunately all you can grab is 1 coin. Hand goes in and now you've at least been able to grab 2 coins. 1, 2, 3, 4, 5, 6. The final option is the hand goes in and I'm able to scoop up all 3 of the coins into my hand. So 1, 2, 3, 4, 5, 6, 7 different sums of money. Fantastic question. Excellent test question. Okay, let's keep going. Now all of a sudden we're in Timmy's. And again, same scenario. This time I got 3 quarters in the bottom of my purse, a penny, and 2 nickels. I don't think I'm going to be able to buy anything, but hopefully you'll lend me some. Okay, so how do I do this if I've got 3 quarters, 1 penny, and 2 nickels? Well, these next 2 examples are what we call subsets with repetition. Do you remember when we did the lesson on when we have letters that are alike? Mississippi, schooner, meet, M-E-E-T, golf T, how we dealt with it? Well, look at how we're going to deal with this. I know I've got some quarters in my purse. I know I've got a penny in my purse, and I know I've got some nickels in my purse. When the hand goes in with respect to the quarters, I might come out with 1 quarter. I might come out with 2 quarters. I might come out with 3 quarters, or I might come out with no quarters. So my hand goes to the bottom of the purse. I'm searching around for some money. Hand comes out. I look at what I've got in my hand in terms of change. I might end up with 3 quarters, 2 quarters, 1 quarter, or I might have no quarters at all. 4 options. In terms of the penny, I might have a penny or no penny. 2 options, picked or not picked. In terms of the nickels, I might have 1 nickel, 2 nickels, or I might not have any nickels. So when there's repetition, there's more than 2 choices because of that repetition. So 4 times 2 is 8, times 3 is 24. But again, what we have to very well remember is that within that 24, no quarters, no pennies, no nickels. Null set. How about you take a second and see if you can do the next one with me. 4 pennies, 1 nickel, 1 dime, 1 quarter. What are my options for the 4 pennies if I'm scooping the change out? Well, I might end up with 1. I might end up with 2. I might end up with 3. I might end up with 4, or I might end up with no pennies. 5 choices. What about the 1 nickel? Nickel, no nickel? What about the 1 dime? Dime, no dime? What about the 1 quarter? Quarter, no quarter? So 5 times 2 is 10, 20, 40. But remember what's included in those 40 options. 1 option that says no pennies, no nickels, no dimes, no quarters. That's the option where your hand actually goes into the purse looking for the change, and you can't grab anything because there's so much junk in your purse. So your hand comes out empty-handed. That is not allowed. You're actually looking for a different sum of money. You can't come out empty-handed. Okay. How about you guys try the next one with me here too? You come over to my house, and on the island I have a basket with 3 bananas, 1 apple, 4 pears, and 3 oranges. And you come into the house and you're starving, and I say to you, oh, you're hungry? Well, help yourself. Have something out of the fruit basket. Help yourself. Have something out of the fruit basket. Notice that's not a detailed instruction. That's not saying, yes, you're allowed to have 1 piece of fruit. Or, yes, you can choose 3 pieces of fruit. When somebody says help yourself, or somebody says, take whatever you want, that is the classic subset type of question. Okay, well, if there's 3 bananas, how many options do I have? If there's 1 apple, how many options do I have? Pick that apple, don't pick that apple. If there are 4 pears, how many options do I have? Pick no pears, pick 1 pear, pick 2 pears, pick 3 pears, pick 4 pears. If there are 3 oranges, how many options do I have? So 8 times 5 times 4, 160, but don't forget, the assumption is that you're starving and you're desperate and you're going to go pick a piece of fruit. Beautiful. Okay, will you do me a favor? And will you scoot to our very last example? And will you put some stars beside it, please? Okay, let's take a look at it. A bag of candy has 3 red, I have to write this down, 3 red, 2 blue, and 4 yellow gumballs. So total is 9 gumballs. Okay. A child gets into the bag and eats at least 1. So the assumption, if they eat at least 1, that means they could have eaten 1, 2, 3, 4, 5, 6, 7, 8, or 9 gumballs. That means they're eating something. They didn't just leave them alone. How many different combinations of gumballs could the child have eaten? So again, because the assumption is that we don't know what the kid ate, the kid ate anything between 1 and 9 gumballs. This is a classic subset question. So red, how many choices are there? Blue, how many choices are there? Yellow, how many choices are there? 12 times 5 is 60. But within that 60, again, is the no red, no blue, no yellow. And we've already been told that this kid's eaten a gumball 59 different ways. Okay, let's keep going. We're going to make it a little bit harder. What if we know that the child took at least 2 gumballs? So at least 2 gumballs means 2 gumballs, or 3, or 4, or 5, or 6, or 7, or 8, or 9. Whoa. Well, this kind of sounds like a reverse psych to me. It kind of sounds like no restrictions, minus 0 gumballs, minus 1 gumball. Because opposite to the question, if the question's looking for 2 to 9, opposite would be 0 and 1. Well, no restrictions would be the 4 times the 3 times the 5. That's the classic how many choices. 0 gumballs, there's only one way of eating 0 gumballs. That's this guy right here, no gum. 1 gumball, there are actually 3 ways. A red, a blue, and a yellow. So 60 minus 1 minus 3, 56 different ways for the kid to at least 2 gumballs. Do me a favor, instead of doing C, let's scoot down to D. Because look at the follow through from B to D. How many different ways can the child eat at least 3 gumballs? So that means 3, 4, 5, 6, 7, 8, 9. Again, to me, and we've discussed this about the word at least. At least can either be where you're adding all the options or you're using reverse. But to me, this is an easier reverse question. Opposite to 3 gumballs would be no gumballs, 1 gumball, and 2 gumballs. Okay, so hold on. No restrictions would be the 4 times 3 times 5. 0 gumballs, 1 way. 1 gumball, 3 ways. And what about 2 gumballs? What about 2 gumballs? Well, let's think about this. I could eat red, red. That's 2 gumballs. I could eat blue, blue. That's 2 gumballs. I could eat yellow, yellow. That's 2 gumballs. I could eat 1 red and 1 blue. That's 2 gumballs. I could eat 1 red and 1 yellow. That's 2 gumballs. I could eat 1 blue and 1 yellow. That's also 2 gumballs. Have I made all of the options? Absolutely. Remember, order doesn't matter. So 60 minus 1 minus 3 minus 6. 50 different ways. Okay. Now, let's crank it up to probably the most difficult one. What if the child took at least 2 of each color? At least 2 of each color. So the color has to be the same now. Well, hold on. Let's talk about red. There's 3 reds. So at least 2 would be red, red. At least 2 could be red, 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 because there's a maximum of 3. Blue, there's only 2 gumballs. So you can't go anything over 2 blues if we're keeping the coloring the same. And yellow, 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 and yellow, 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 because there were 4. So at least 2 meant 2 yellows, 3 yellows, or 4 yellows. So what if the child ate at least 2 of each color? There's 2 options for red, 1 option for blue, and 3 options for yellow. Great questions, guys. These are high-end subset. Okay, this is not your classic subset. This is a bit more high-end. At the very bottom of the note, can we just add one little special thing? Okay, before we end off. Words that indicate a subset question. So, words that indicate a subset question. Let's look back at my note for a second. Any. Very open-ended. Pick whatever you want. Any. As many or as few. Again, very open-ended. Different. At least. So again, throughout this entire unit, we've really been discovering the importance of words, especially little words that you can often sort of read over quite quickly and not really pick up on their meaning, but I'm hoping by pointing out the importance of these words, it's helping you when you're doing your homework and they're standing out to you. So last official lesson, we're going to get ourselves ready here in the next couple of days with an assignment and a colored sheet and all that good stuff for our very first test. Okay, thanks again.